All right, moving into Module 6, we are going to start looking at linear functions. And a linear function is a function whose graph forms a line that is not vertical. So if it is a vertical line, that's a straight up and down line, that's not a function because the x values repeat, and it wouldn't classify as a function, therefore it can't classify as a linear function. Linear equation is an equation that can be written in standard form. And standard form is a times x plus b times y equals c, where a, b, and c are going to be real numbers. And a and b are not both 0. It's okay for one of them to be 0, but it's not okay for a and b to both be 0 at the same time. If you were to simplify these and rearrange these equations in standard form, we would get something that looks like y equals mx or y equals mx plus b. So in order to be, when a linear equation is written in standard form, the following are true. If it's in standard form, x and y both have exponents of 1. So in other words, it's just x and y. It's not x to the third power. It's not y to the fourth power. It's just x or y. And then our second one here, x and y are not multiplied together. So we cannot have x times y in our equation. And then the third one, x and y do not appear in denominators, exponents, or radicands. So for instance, we cannot have something like this, 3 over x. We cannot have that. We could have, so this is a no, we could have x over 3. So that would be a yes, because that's not the denominator, that's in the numerator. X cannot be our exponent, or y can't be our exponent, so we can't have 3 to the y, or 5 to the x. Can't be exponents, so those are no's. And it cannot be under a radicand. So in other words, we can't take the square root of x or y, or maybe 3y. Those variables cannot be under those radicals. All right, so tell whether each equation is linear. If so, graph the function. So we're going to look at this equation, and we're going to go through these 3 dots. It is in the form of ax plus by equals c. So our a would be negative 12. Our b would be 1 because that's 1y, and c is negative 4 here. So that is in ax plus by equals c form. So our x and y both have exponents of 1. X and y are not being multiplied together. They're not in a denominator. They're not as an exponent, and they're not under a radical symbol or a radicand symbol. So yes, this would be linear. So it passed all 3 of those bullets up there. And then it says to graph this function. So what I'm going to do to make it just a little bit easier is I'm going to solve this equation for y. So in order to get rid of that minus 12x, I'm going to add 12x to both sides. And I'm going to have y equals negative 4 plus 12x. And I'm going to rearrange that. I'm going to have 12x minus 4 because that's the form of y equals mx plus b. So actually, I'm going to make this down a little bit farther. And I'm going to go by 2s, 2, 4, 6, 8, 10. So this would be negative 4, this would be positive 4, 6, this would be positive 8 here. So each tick mark there represents a 2. And then I'm going to go by 1s on the x-axis. And this number here, the b value, is our y-intercept. So we're going to have a circle on the y-axis at negative 4. And then our slope is 12. So that means 12 as a fraction is 12 over 1. So I'm going to go up 12 and over 1. So I'm going to remember that my tick marks are 2s. So 2, 4, 6, 8, 10, 12. So I'm here, and then I have to move over 1. So I'm going to be right there. And then I can, connect those dots and make my line. All right, so here, part B, we have y equals 23x squared minus 4. So going back here, x and y both have exponents of 1. No, x has an exponent of 2. So this right now, it failed the first bullet mark there. So no, this is not a linear function. And then here, we have xy minus 4 equals 12. Back up here to the bullets, the first one, x and y both have exponents of 1. That's true. Number 2, x and y are not multiplied together, but x and y are multiplied together here, so this is a no as well. Then example 2, it says write each equation in standard form and then graph each line. So this one is in standard form because the standard form is ax plus by equals c. There's no x involved, so that means our a had to have been 0. So it was 0x plus, there's no number in front of y, so that's a 1. So 1y and then equals 8. So that's what it looks like in kind of expanded standard form. Y equals 8 is simplified down with all the stuff that we don't need written. So it's in standard form, and then we need to graph that. So we're going to have a graph here, 2, 4, 6, 8, 10. So y equals 8 is right here on the y-axis. Here is 8. So it's going to be a straight across line because there's no x value. So no matter what I plug in for x, I have to times it by 0. So it's going to go away anyway, and I'm going to be left with y equals 8. So it's going to be a horizontal line across the y-axis at 8. Then for part B, we have x equals -1. So same thing. If the ax plus by equals c, x here, a is 1, so we have 1x. We don't have a y, so that means our b value was 0. So 0y equals, our c would be -1. So in order to graph that, notice this one says x equals -1, so that means I have to go to the x-axis and find -1. It's right here. And this one is going to be a vertical line straight up and down because there's no y, so no matter what our y value is, it's going to cancel out, and we're just going to be left with that x equals -1. So if I plug in ordered pairs, if you think about ordered pairs, I have to go over -1, and I can go up or down anything because y can be anything because it's going to be times by 0. So that is the graph for this, but this is not considered a linear function because our x value repeats, no matter what, our x is -1. So -1 is repeated in every single ordered pair. Even though it does form a straight line, it's not a linear function. All right, in example 3, tell whether the equation represents a horizontal line, a vertical line, or neither, and then graph the equation. So looking back up here, if it was x equals a number, it's going to be a straight up and down, so a vertical line. And then if it was y equals a number, it's going to be a horizontal line. So if we have anything other than just x equals a number or y equals a number, then we're going to have an angle, a line that's on an angle. So looking at part A, this is y equals 2x, so we have both variables in there, so that's going to be a neither. And then looking over here, y equals -4, that's going to go through the y-axis at -4. So this is going to be a horizontal line. And then to graph, I'm going to put them both on the same line here, or same graph. This is y equals 2x plus 0 because we don't have a b value, so it's got to be a 0. So we're going to start at 0, 0. And then our slope is 2. If we make that a fraction, it's 2 over 1. So that means our rise 2, run 1. So up 2 over 1 would be right here. And that, well, can't draw a straight line on here. So that would be the graph of that line. And then y equals -4. So if I went down to -4, it's going to be here no matter what x is. Our y value would be a -4. All right, and then for our last two, we're going to have to solve for y here. So I'm going to divide by 3. So y equals -4/3. And then this one over here, I'm going to minus 3. So 0 minus 3 is -3, so x equals -3. So this is y equals a number, no x value. So this is going to be a horizontal line. And x equals -3 would be a vertical line because it's going to go through the x-axis at -3. So if I graph, -4/3 is like -1 1/3. So -1 and then just past that a little bit. So right about here would be that line. And then x equals -3. Here's x equals -3 over here. So no matter what y is, x will be -3 and it would look like that.